Welcome learners. This is Dr. T. Gangaram, lecturer in statistics, SVA Government College, Srikalahasti. In this video lecture, a procedure for derivation of Newton's forward formula along with an example. The conditions and assumptions are: for Newton's forward formula to be applicable, the following conditions must be met. The function y is equal to f of x must be an nth degree polynomial and the arguments of independent variable x must lie at equal intervals with common difference h. The interpolated argument x must lie at the beginning of the given set of arguments. We use forward difference operator delta for Newton's forward formula. Let x0 plus h, x0 plus 2h and so on, x0 plus nh be values of n independent variables at equal intervals with the difference of interval h, and y0, y1, y2, yn be the corresponding values of the dependent variable y is equal to f of x. The Newton's forward formula is given by y is equal to f of x is equal to y0 plus uc1 delta y0 plus uc2 delta square y0 so on ucn delta power n y0. Here u, the shift parameter, u is equal to x minus x0 by h. Here x is the interpolated value, x0 is the beginning of the argument, h is the interval of difference. UCR is the binomial expansion, simplification of binomial expansion. We know that NCR is equal to n factorial into n minus r, n factorial divided by r factorial into n minus r factorial up to n minus r factorial up to n minus r. Numerator and the denominator gets cancelled and the remaining terms are u, u minus 1, u minus 2, u minus r plus 1 by r factorial. Proof of the Newton's forward formula. Let n be the nth degree polynomial passing through x0, y0, x1, y1 and so on xn, yn be f of x is equal to a0 plus a1 x minus x0 plus a2 x minus x0 into x minus x1 plus a3 into x minus x0 x minus x1 into x minus x2 so on an x minus x0 so on x minus x n minus 1. This is the nth degree polynomial through the paired values of x and y. Our target is to find the coefficient terms a0, a1, a2 so on an first and then find x minus x0 and x minus x0 into x minus x1. After substituting these two terms, we can get the derivation of Newton's forward formula. Finding a0, the a0, substitute x is equal to x0 in equation 1, a0 plus a1 into x0 minus x0, a2 into x0 minus x0. So the terms became 0. The terms next to a0 became 0. So a0 is equal to y0. The coefficient a0 is equal to y0. Similarly, substitute x is equal to x1 in equation 1. Here x1 minus x0, x1 minus x0, x1 minus x1 minus x1 becomes 0. Up to two terms only remains. So a0 plus a1 into x1 minus x0 remains. Since this is the difference, x1 minus x0 is equal to h, x2 minus x0 is equal to 2h. So substitute instead of x1 minus x0 h. So y1 is equal to, instead of a0 we can substitute y0, instead of a1 x1 minus x0 we can use h. It is the difference. So ah is equal to y1 minus y0, a1 is equal to y1 minus y0 by h. That is equal to, we can write a1 as delta y0 by h, since delta y0 is equal to y1 minus y0. So similarly, by substituting x2, x3 and so on using higher order differences, we can find the coefficients a2 as delta square y0 by 2 factorial into h square, a3 is equal to delta cube y0 by 3 factorial into h cube, so on. An is equal to delta power n y0 by n factorial into h power n. Substituting these values back into equation 1, instead of a1, a0, a1, a2 and so on, we will get y is equal to y0 plus delta y0 by 1 factorial into h into x minus x0, delta square y0 by 2 factorial into h square into x minus x0 into x minus x1, so on. Now we will find the x minus x0 terms. Let u is the shift parameter x minus x0 by h. This implies x minus x0 is equal to u into h. Similarly, x minus x1 is equal to x minus x0 plus h. x1 is equal to, we can find x1 by adding x0 the interval, we can get x1. So x minus x0 plus h. We can write x1 is equal to x0 plus h. This is equal to x minus x0 minus h. This is x minus x0 is equal to uh. We find already. So x minus x0 is equal to uh minus h. By commoning h, we will get h into u minus 1. Similarly, x minus x2 is equal to, we can write x minus x2 as x minus x0 plus x0 minus x2. Here x2 minus x0 is the 2 times the interval. So we can write 2h. X minus x0 minus 2h. Already x minus x0 is equal to uh. By commoning h, we can get h into u minus 2. Similarly, substituting these into the terms, first term is delta y0 by h into uh, x minus x0 is equal to h gets cancelled, u into delta y0 remains. Second term, delta square y0 by 2 factorial into h square, h into u minus 1. This h into h square, and the denominator h square gets cancelled. The terms remaining is here u minus 1 by 2 factorial into delta square y0. Similarly, by summing all the terms, we get y0, y is equal to y0 plus u by 1 factorial into delta y0 plus u into u minus 1 by 2 factorial into delta square y0, so on, u into u minus 1, so on, u minus n plus 1 by n factorial into delta power n y0. In binomial notation, we can write the Newton forward interpolation formula as y is equal to y0 plus uc1 delta y0 plus uc2 delta square y0, so on, ucn delta power n y0. To understand the formula, we can find a missing term using the Newton's forward formula. Determine the value of y when the value of x is equal to 0.456 using the given table of the probability integral y is equal to 1 by root 2 pi integral 0 to x e power minus x square dx. This is the table. When x is equal to 0.45, the value of y is equal to 0.475482. Like that, it is within the interval 0.01. Here, since the interpolated value x is 0.456, it is in between 0.45 into 0.46. It is near the beginning of the table. X0 is equal to 0.45. We can apply Newton's forward interpolation formula. First, we calculate the differences delta y, delta square y, and delta cube y This is the difference table. These are the independent variable values, y values, and delta y, delta square y, delta cube y. The terms, the values in bold represent y naught. This is y naught, this is delta y naught, this is delta square y naught, and this is delta cube y naught. Since we are using these terms only in Newton forward interpolation formula. From the table and the problem statement, we identify the shift to find the shift parameter x naught is equal to the beginning term 0.45, target value, interpolated value x is equal to 0.456, the width h is equal to 0.46 minus 0.45, that is 0.01. Calculate the shift parameter u x minus x naught by h, that is nothing but 0.6. U here is 0.6. Simply substitute these values in Newton's forward formula, that is y of x is equal to y naught plus delta y naught plus u into u minus 1 by 2 factorial into delta square y naught, so on, plus u into u minus 1 delta u minus 2 by 3 factorial into delta cube y naught. Substituting the values, we can get y of 0.5456 is equal to, by simplifying, we can get the y of 0.456 is equal to 0.47949444. This is approximately 0.479494. Newton's forward difference formula is ideal for values near x naught. If the target x were at the end of the table, for example, if the interpolated value, if we need to find x is equal to 0.488, Newton's backward formula would be more accurate. We can derive this Newton's backward formula in the next lecture. Thank you.